Good morning, everyone. Welcome to the lesson 4.4 video. We're actually going to start this one with a do now problem. So go ahead and pause the video and find the midpoint between these 2 points. All right, I'm hoping that we actually paused it. We'll see. I know that we don't always. That's okay. So here's how we would find the midpoint. I'm going to label it my 2 points, x1, y1, x2, y2. And remember, my final answer should be another point. So I need to find my x value and my y value. To find xm, we take x1, add it to x2, divide by 2. So that's going to be 9 plus 7 divided by 2, 16 over 2. That'll give us 8. And then for our y, for our midpoint, we're going to take y1 plus y2. It's basically the same process. Go ahead and plug everything in. 10 plus 16 divided by 2. That's 26 divided by 2. That's 13. So our final answer here is the point 8, 13. I like to throw these do now problems in every now and then to keep you on your toes, to make sure that we are remembering stuff that we learned even a year or two ago or at the beginning of this class. So that's our little throwback to the midpoint. Let's get into 4.4. So today we're talking about 2 other postulates or theorems that will help us to prove 2 triangles are congruent. We're going to talk about this one called the angle side angle one and another called the angle side postulate. So ASA, AAS. These combined with the 2 we talked about yesterday, SSS, SAS. These are going to be like the big 4 for us. We're going to sit on these for a little while. We're going to take a quiz early next week. I'm hoping for Tuesday. And we're going to be able to solve a lot of proofs with these 4 postulates. So our objectives, we're proving triangles are congruent using these 2. One of them is called a postulate, one is a theorem. We don't need to get too in the weeds about that. It's just how they're named. And then we're going to identify, like, when is it appropriate to use which of these postulates or theorems. So here's our first postulate. It's our angle side angle one, ASA. So this one says if you have one pair of angles that are congruent, another pair of angles that are congruent, and then you have this included side pair, then that's enough information to say that these 2 triangles are congruent. So A is congruent with D, C is congruent with F, and the included sides here are also congruent. They're using that terminology over here. The included sides here are also congruent. Then we're using our angle side angle. And remember, use the order of the letters here to help you out. It should be angle, side, angle. The side should be in between the 2 angles that you're using in your postulate, in your proof. So, looking at these 4 triangles, which 2 could we say are congruent by our angle side angle postulate? So we are looking for triangles that have 2 pairs of congruent sides. Well, all of these have 2 pairs of congruent sides, right? Like that angle is congruent to that one, which is congruent to that one, is congruent to that one. But to use angle side angle, we need to make sure that our congruent pair of sides is included. So take a second. We should be getting B and D. I have this pair of angles, this pair of angles, and then the sides that are congruent are right between those 2 angles in my triangle, angle side angle. We're moving right along to our last theorem for this section. Really, to understand these and to get a good concept, I need you to practice. So you're going to have a few worksheets that you're working through today. You're going to have a few proofs that you're working through today. We got to just practice, and these will get really comfortable. So for this one, we're saying I have one pair of angles congruent, second pair of angles congruent, and then any old side. This side does not have to be between those 2, right? That was our last one, angle side angle. Here they use the term non-included side of one triangle is congruent to the other triangle. So that's enough information to say that these 2 triangles are congruent. Once again, follow the letters, angle, angle, side. When we look at one of these triangles, you can kind of follow it, angle, angle, side, okay? So let's actually go ahead and try a proof. I think it's time. Okay, so we have a couple givens. Ray DB, this red line over here, bisects angle ABC. That's this angle over here. And then they're also telling us that angle 1 is congruent to angle 2. So let's go ahead and start our proof. Our first reason is given. Let's write our first given. Ray DB bisects angle ABC. What can I do with that? Like, what does it mean for something to bisect? How can we use that information to make another statement here? Remember, our end goal is this. I'm trying to prove these triangles congruent. To do that, I need to prove that pairs of angles or sides are also congruent. So if Ray DB bisects this angle ABC over here, well, that's telling me that these two halves must be congruent. So we can say that angle 3 is congruent to angle 4. Why? That's our definition of an angle bisector. All right, our third statement. Since our reason is given, we're just writing down our other given. Angle 1 is congruent to angle 2. We're doing really well. I have 2 pairs of congruent angles. I need to prove some other pair of something congruent. Where would you go from here? What would your next step be? So remember, a shortcut we kind of talked about yesterday was anytime you're dealing with a shape like this where you have a shared side, chances are you're going to use your reflexive property. So we can actually go ahead and say that segment BD is congruent to segment BD. I know it sounds silly to say that, but you need to state every single pair of congruent angles and congruent sides in order to use the postulate or theorem that you're trying to use. So our reason for this, that's our reflexive property. Something equals itself. Think reflexive, reflective, it equals itself. All right, I have angle, angle, side. Should I be using angle, angle, side, or should I use angle, side, angle? So because of what we have over here, let me erase some of the markings on this diagram over here. Because we have this pair of angles congruent, this pair of angles congruent, and the side that's included between them, we're going to go ahead and use angle, side, angle. So I can say triangle DAB is congruent to triangle DCB. I'm using my angle, side, angle postulate. And that's it. So I know proofs can seem daunting. Take it step by step. Start with your givens and then ask yourself, okay, how can I use that given to prove a pair of something, angles or sides, congruent? And then once you have a bunch of angles and sides congruent, well, which postulate could you apply here to prove the triangles are congruent? Good work with that. Let's move on to another one. This one's a little exciting. There are no boxes here. It's just a blank proof. I'm going to give you some worksheets to work on that are kind of similar to this. So we're just getting some practice now. It's still a proof. You know how to do proofs. I trust you all with that. But let's practice starting from scratch here. So first thing we're going to do is we're going to write down our givens. Angle B and angle E are right angles. That's a given. What can I do with that? How does that help me? What does it mean for things to be right angles? Well, they equal 90 degrees. If they equal 90 degrees, then they must be congruent. So I'm going to go ahead and say angle B is congruent with angle E. Remember, you have to make that statement if you're trying to prove triangles congruent. And my reason here, just definition of right angles. Okay, cool. 3, let's throw our other given in there. So C is the midpoint of segment AD. If C is the midpoint of this whole segment over here, what does that do for us? What does that mean? What can I say with that? How can I use that to help me prove either a pair of angles congruent or a pair of sides congruent? So remember, a midpoint cuts something exactly in half. So I can say here, I'll go back to red for a second, that this little segment must be congruent with that little segment, right? If C is the midpoint, it cuts AD exactly in half. So AC must be congruent to DC. And I ordered the letters that way because I think it looks to me like A and D are going to be corresponding letters. So that's why I did DC instead of CD, okay? Ooh, forgot to write given for our last one. All right, so what was our reasoning for 4? How could I say this over here? Definition of midpoint. We're using our given, and we're letting it kind of guide us into a statement that's going to help us prove these things congruent. So remember yesterday how I said anytime you see a bow tie looking shape like this, chances are we're going to use vertical angles theorem. This is a perfect example of that. Okay, I have this bow tie shape. I have angle 1 and angle 2. They're vertical angles. Let's use that to our advantage and say that angle 1 is congruent with angle 2. Why? Well, because vertical angles are always congruent based on our vertical angle theorem. I have a pair of angles that are congruent. I have a pair of sides that are congruent. I have another pair of angles that are congruent. Check the order of these in our diagrams. I have angle, angle, side. So I'm going to use angle, angle, side. Triangle ABC is congruent to triangle DEC by my angle, angle, side theorem. All right, you have completed another proof. Good work. Good job. I'll erase some of the stuff here so we can look at a nice clean diagram. We have one last thing we're going to do today, and then you'll have a few worksheets to work on. You'll have one where you're just identifying where it's appropriate to use which postulate and theorem, and you will have some proofs. So treat these like a puzzle. They can actually be kind of fun if you let them be kind of fun. Let them guide you, right? Try to follow the logic of what's happening, and you can work together on them. All right, last thing here. Each pair of triangles is congruent by one of these. We're trying to identify which one. On your worksheet, you might have some that are not enough information, okay? Here, we should be able to identify most of them, but we'll see. So this first one, I can see that I have a lot of info about sides. I have 3 pairs of congruent sides. I'm going to use my side, side, side postulate. For B, I see 2 pairs of congruent angles, 1 pair of congruent sides. Check where that side is. Well, it's not included, so this would be angle, angle, side. For C, I have 2 pairs of angles and 1 pair of sides. The side is included, so we're going to use angle, side, angle for that one. And lastly, this one we kind of have to stretch a little bit. I see 2 pairs of congruent sides. Because it's a bow tie shape, you know these angles are congruent. That's enough info for us to use side, angle, side. And with that, your lesson is done for 4.4. Good work. Now go ahead and work on those worksheets. Like I said, you'll have some similar to example 4 here where you're just identifying which postulate you could use, or if you don't have enough information to use any. And then your second worksheet will be actual proof practice. So you'll be practicing using angle, side, angle, and angle, angle, side in the context of proofs. You have a couple of homework problems, nothing too long. Once again, just more practice. I want you to be so wildly comfortable and confident with this stuff. All right, with that, I'll say goodbye.